To create the Lego helicopter, we're going to go through and follow the Lego instructions like you would if you were making the Lego model in real life. The kit comes with 70 pieces, but there's actually only 31 unique parts because some of them are used more than once. And of those 31, some of them are very similar to each other, so we don't really have to make 31 completely different parts. So starting with step 1 here, we've got 4 different parts to make this first stage. We're going to make those parts one by one, and we're going to start with probably the simplest one, the axle here. If we look at the instructions, we can see there's a number 3 next to the axle, and that indicates the length of it. That means that it's actually 3 bricks long, and if we put it inside the bricks like this, you can see it goes through 3 sets of bricks. So we're going to open up SolidWorks and start to create this part. And once SolidWorks is open for you, just start a new part. So here we are in a completely blank part. And when we start a new SolidWorks part, we usually start on one of these 3 default planes, the front plane, the top plane, or the right plane. Now, sometimes when you look at the items you're making in SolidWorks, there'll be a really obvious top or side or front of the part, and you can line those up with the planes in SolidWorks. But actually, in the case of this part, the Lego axle, it doesn't really matter too much which direction is the front, the top, or the side. So with this part, don't get too hung up on which plane you should start on. In this case, I'm going to start on the front plane, so I'm going to left click to select that plane, and then I'm going to choose Sketch from the pop-up menu, which will start a new sketch. So now we've moved to a normal 2 view, and we're sketching on the front plane. The first thing that I'm going to do is draw that cross shape, which is a cross section of the axle. To do this, I'm going to draw 2 rectangles. So I'm going to go to the Sketch tab, choose the rectangle tool, and we want to choose a center rectangle, which is the second option here. So you can click on the little drop down and you can choose center rectangle directly up there on the command manager, or you can just choose the tool and you can choose center rectangle here on the left. So if we look at the little icon in the tool, you can see there's 2 numbers. Number 1 indicates the first click, so the first click sets the center of the rectangle, and then number 2 indicates the second click, so that sets the overall size of the rectangle. So I'm going to move into the graphics area, I'm going to start at the origin, and I'm going to left click once at the origin to set the center of the rectangle, and then move the mouse out, and then I'm going to click again to set the size of the rectangle. So we want something like this. And then remaining in the center rectangle tool, I'm going to go back to the origin and I'm going to draw another rectangle, but this time in this sort of direction. So this one should also be linked to the origin. And then I'm going to press the escape key just to close the rectangle tool. Now when you're drawing your sketches, it's a good idea to always try to link them to a fixed point, which in this case is the origin. This then allows you to fully define your sketches, so they won't move around or change shape or size when you don't want them to. So now that we have our 2 rectangles, we're going to use the Smart Dimension tool to set the size of them. Choose the Smart Dimension tool from the command manager, and then I'm going to set the size of this rectangle at the top here. You can see when I choose that line, it's coming up on my view as 36 millimeters. But I'm going to change that to 1.8 millimeters, which is what I've measured from the axle using my digital calipers. And now you can see when I add that first dimension, the whole sketch has resized automatically. This only happens when you add the first dimension of the sketch. And then for the height here, I'm going to choose this line by left clicking, and I'm going to make that 4.7 millimeters. Now we want to make the second rectangle the same size as the first. We could add some more dimensions, but instead we're going to use relations. So I'm going to press escape to close the Smart Dimension tool. And what we're going to do is select this small line that we've already dimensioned. So left click on it to select it, and then hold down the control key. This allows you to select multiple items. Then we're also going to select this second line here. Now I'm going to release the control key, and you can see we get this pop-up menu with different relations on it. From the pop-up, I'm going to choose this one, which is Make Equal. You can also choose it here on the left. It's exactly the same setting. So by clicking that, it means that both of those lines are now an equal length. They're both the same size. And if we click on one of those lines, we can now see we've got that equal symbol on both of the lines. Then we're going to do the same thing with the longer line. So I'm going to select the one that we've already dimensioned, hold down Control, and then select the second one, and then release Control, and then from the menu that pops up, let's choose Make Equal. So those lines are now the same size, and you'll notice that the entire sketch has turned black. This means that it's fully defined. And we also have a message down here that says the sketch is fully defined. This is because both of these rectangles are fixed to the origin, so they can't move in position, And then we've set the size of both of them as well, so they can't change in size. So we could now extrude this cross-shaped profile to make our axle shape. But actually, if we look really closely at the axle and we look at it from the end, we can see that these edge faces aren't actually completely square. They're slightly rounded. And this is so that we can put the axle into a round hole and it will still spin round properly. But if we actually look at that part, it's going to be really hard to measure that radius. But what we do know is that the widest length across that axle is 4.7. So what we can do is get the circle tool from the sketch tab. Then let's draw a circle that's fixed at the origin and drag it out to about this size. Then press the escape key to close the circle tool. We can then left click to select that circle, hold down Control, which allows you to select multiple items, and then we can select one of these small straight lines. Then release Control, and from the menu that pops up, let's choose Make Tangent. So now that circle is exactly touching that small straight line. And that will just give us that slight radius that we have there that lets the axle spin properly in the hole. So now we have everything we need in terms of our sketch, and we can extrude this profile to create the axle. We can stay within the sketch, we don't have to exit, but let's go to the Features tab and let's choose Extruded Boss Base, the first option here. We can now see that we don't get any kind of preview for the extrude. And that's because we've got these overlapping profiles within the sketch. So SolidWorks doesn't really know which areas of the sketch we want to extrude. So we have to choose those manually. And you can actually see if I hover over these different enclosed areas in the profile, they turn red. And that indicates that we can select those areas. So let's select all the areas we want to extrude. So there's 4 outer areas of the cross shape, and then there's that center section as well. And now we can see there on the preview, we've got that cross shape, but the edges of the cross are slightly curved. If you're having any trouble selecting those areas, you might just have to click down here in this selected contours box here on the left, and then choose those 5 different areas. So we've got that center section, and then we've got those 4 sections around the outside. Now we can extrude this axle shape the exact length that we want. But before we do set the length, I'm going to change the end condition from blind to mid-plane. This means that instead of extruding in just one single direction, we're going to be extruding in 2 directions from the sketch by an equal amount. And then we can set the exact length, and we know from measuring it with the calipers that that's 23.45 millimeters. And we can see on the preview that we're going to be extruding equally in each direction. When you're happy with that, you can press OK to create that feature. And now we've created that basic axle shape. Now if we look at the axle part in real life very closely, there's actually a lot more detail than we can see here on the model. We've got some parting lines on there from where the mold moved apart. We've got some ejector pin marks from probably where the part was pushed out of the mold. And sometimes you've even got small part numbers and things like that. In this case, we've got some slightly rounded edges to help you put the part into the other bricks. And it's really up to you how much detail you want to model at this stage. This really is a trade-off between how much time you want to spend and how accurate you want your parts to be. I would personally say that we don't actually need all of that super fine detail, but what we will do instead is just round off the edges of the axle here. So let's select the fillet tool from the Features tab, and I'm going to make a fillet that's 0.5 millimeters in size. It's just symmetric, a circular profile, and I'm going to select these 4 edges around here. So there's 4 on this end, and then there's another 4 on the other end. If you find that you accidentally select the wrong face or edge, you can just click it again to deselect it. So we're going to add those 4 fillets on each end, 8 in total, and then press OK. And now we've got our basic axle model there, and that's all there is to this first part. We can now save the part, and you can do this by pressing Ctrl S. You can press the save icon, or you can go to File, Save. I'm going to go to my working folder where I'm going to put all these different Lego parts, and I'm going to call this part something descriptive like axle. Now before you press OK, whenever we're saving parts in SolidWorks, try to avoid quite generic names, things like block or axle or connector. That's because if you create a similar project in future, maybe something that isn't Lego, but something that also uses an axle, then it might cause problems to your assembly if you've got multiple parts named the same thing in different locations. You might end up using the wrong part in your new assembly. So to try to avoid this, I'd recommend adding some kind of unique identifier to your parts. This could be just something like the date, or it could be a part number. You could maybe even write something like Lego Chopper Axle. But what I'm going to do is write axle, and then I'm just going to add on 30465, which is just the model number of this Lego kit. And I'm going to add that number to all of my parts just to make them unique to this project. So I'm going to say axle 30465, and I'm going to save that part. And that's all there is to that first part. So we've got 1 down, 30 to go. But actually some of the later ones are very similar to these early ones, so we can just copy and paste them and make some small changes. So to very quickly recap this part, we just made a simple extrude using that cross shape with the rounded edges, and then we filleted the edges there. In the next video, we'll start making the next part, which is that right angle beam, which makes up the side of the fuselage or the body of the helicopter.